Thank you for joining me today. I'm going to be talking to you about finding area of triangles. Alright, but before we get started in some examples, let's take a look at what you're going to need to know. First of all, what is area? Again, this is simply the number of square units that make up the inside of a figure. Okay, and this is always going to be measured in inches squared because we use two dimensions to measure that. Typically length and width or base and height. Okay, so for a triangle we're actually going to use base and height. You can see the formula here, 1/2 base times height, or you can also write it as base times height divided by 2. Completely up to you. Just a quick reminder that when you multiply by 1/2, it's exactly like dividing something by 2. So either way is fine. So let's take a look at some examples. Really quickly, one of the most common examples you're going to see is something just like this. It's what we call a right triangle or a 90-degree triangle. All right. The height of the triangle is always going to be along the side that makes up the 90-degree angle. Okay, and the base should be as well. So these two dimensions right here should be our base and height. This is what I call a distractor. It actually has another name. It's called the hypotenuse, which you'll learn later on down the line. However, we won't use 11. You can ignore that dimension. You don't need to use it. All right, we're going to use 6 and 8, and we're going to plug these values into the area formula, 1/2 base times height. So we're going to go ahead and use 6 as our base, so that's 1/2 times 6, and 8 as our height. Alright, so you have a couple options here. You can go ahead and take half of 6 and make it 3, then multiply by 8, or you can multiply 6 and 8 together and divide those by 2. Again, there's a lot you can do because multiplication is commutative, which means the order in which you multiply them isn't going to matter. Let's just go ahead and take half of 6, which is going to be 3. And that'll make our final multiplication a little bit easier there. 8 times 3 then is going to be 24. So what you end up with then is area equals 24 centimeters. And like I said before, that's going to be measured in squared units, base and height, 2 units. Alright, so let's take a look at another one. Similar example, you can just see they'll take the triangles and they'll flip them around, they'll rotate them. But really what you're looking for, again, to define what base and height are, is simply that 90-degree angle, because the two legs that make up that angle will be your base and height. So we can go ahead and make 8 our base and 9 our height, and we'll simply ignore that 12. We don't need to use it. So area equals 1/2 base times height. So that's going to be 1/2 times 8 times 9. Just like that. So you can use a similar strategy here. You can see that 8 and 1/2, or 8 divided by 2, would be compatible. So we can easily divide 8 in half to give us 4. Doing little tricks like that using compatible numbers and division can make everything else seem a little bit easier. So instead of having to multiply 8 and 9 and then divide that in half, we can just simply do 4 times 9, which is going to be 36. So you're looking at 36 inches squared. Alright, for the next example, you can see we have a different looking type of triangle here. This is more almost, we would call it a scalene triangle because it has, or possibly an isosceles. They don't define what that third side is. However, it's not a right triangle, but you can see they do create a right triangle in the middle, and they have to do that to define what the height is. 11 is not the height. Okay, again, the height of a triangle has to be connected, or a vertical 90-degree line, okay, with the base. So you can see they've already shown us here by pointing an arrow in that 8 would actually end up being the dimension that goes along that line. So the 8 is going to be our height, and 21 is going to be our base. 11 just represents, again, what we would typically call a hypotenuse, or just another side of the triangle. Alright, so let's go ahead and plug into our formula. Area equals 1/2 8 times 21. Whoops. So I'm going to use a similar strategy that I used a moment ago, because 1/2 of 8 is easy to find. It's 4. So I'm going to say area equals 4 times 21, and you can see that makes and creates a little easier multiplication. 21 times 4 off to the side, 4 times 1 is 4, 4 times 2 is 8, and so you get your area formula, or your area, excuse me, of the triangle of being area equals 84 inches squared. All right. One more example here. This one is, again, more of like a scalene. This time you can define it as a scalene triangle, which means all the sides are different. In this case, you can see, again, they've given us the height along that dashed line. That vertical line that comes down to the 90-degree angle is your height. So we're going to use 11. And our base, again, is connected to the 90-degree angle as well. So that means our base is going to be 24. So why do they give us those other sides? Well, again, they're trying to distract you with them to make sure, to actually just assess whether or not you can find the base and height of this triangle. So we're going to substitute those values in. Area equals 1/2 times base, which is 24, times height, which is 11. So in this case, again, we're lucky that we get an even number, 24, that we can divide in half. So that's going to be area equals 12 times 11. So we can go ahead and do that multiplication to make sure we don't make any careless errors with mental math. 1 times 2 is 2. 1 times 1 is 1. Then 1 times 2 again, and 1 times 1 again. So we add up, and you see we get 132. So area equals 132 centimeters squared. All right, this has been a quick tutorial on how to find the area of a triangle. Thank you for joining me.